Let's go. Good evening. I would like to welcome you all to my presentation. I will give you a quick overview over my bachelor's thesis. It was about the calibration of an automotive R&D instrument, and I'll show you in the next slide. The project was about implementing a field calibration system for the devices you can see on screen. They are usually used within automotive development cars, and they can do a lot of things, but for my thesis it was relevant the voltage measuring system, subsystem of the device. The whole field calibration system is built like that. There's a precision voltage source you can see on the upper side, then there's a multiplexer circuit board, and finally the backside of the device at the lower part of the slide. For my project, I implemented a bunch of hardware and software. Here you can see an overview of the software architecture of what I implemented. In the middle you can see, you can see actually, nice. You can see all the different software modules I've implemented and developed and how they interact with each other. Then for the next slide, I've prepared the part of the thesis was preparing the actual calibration procedure that was derived from the German national standards, how to, like the VDE. Each calibration goes after first the prerequisite get checked, then the measuring points get recorded, then there's an option to write the calibration to the device or not. Everything gets put into protocol, of course, and any errors get reported and also put in a protocol. And then you can start from the beginning. Thank you very much for listening.
Good evening, everyone. My name is Yong Jing. Today I would like to present one of my favorite projects I did in the last semester, which is OptiSkate. It has the meaning of optimization of an inline skate. So in this project, we are aiming to help, especially for the beginner, to learn how to skate with a proper way and proper methods by integrating our innovative mechatronic system. And we hope at the end of with the results, we can introduce a more scientific techniques for them to learn a new skills. So in the project development, we have the hardware of 3D printing case to locate our sensors, force sensor, to sense the force exerted by the user, and we interpret the data and conclude it with different skills, for example, turning and also stopping. And of course, we face some problem during the project development, for example, the orientation of the sensors, the connection, and also the real-time reading. But slowly, we solve the question or problem one by one, and we are happy to see the result with the interpreted graph. For example, the techniques of turning, straightening, and pre-stops. And thank you for your attention.
Can you see me? Yes. Hello everyone, my name is Nebojša, and today I will present you the project that I did over the past semester along with my colleagues from Brazil. Those colleagues are studying electrotechnics, and I'm a student of mechatronics here at the Hochschule Karlsruhe. The project, as the name says, was the application of Intel RealSense D455 depth camera. So what is a depth camera? Depth camera is a device which has different sensors. It consists of one RGB sensor, like normal camera, two depth sensors, and one infrared camera. So in order to implement depth camera, we need some kind of software or software development kit. So among the other software that we found online, we decided to use NUITRAC along with Unity. I suppose that everybody of you are familiar with Unity, so I will just explain what NUITRAC is. So NUITRAC is the software which is free to use for students and for little projects, which allow us to, by usage of depth camera, track the full body skeletal, to make user masks, to make a 3D point cloud, to recognize some gestures, and also it's capable of face tracking. So our goal was to utilize NUITRAC and to experiment with the camera to see what are its possibilities. So here are our results. This is my colleague, Giovanna. So we have used this software. We tried to implement gesture recognition to make a virtual changing room, which means basically we utilized some models from Unity Asset Store and implemented them in our project in order to make a virtual fitting room. The video itself is almost 2 minutes, so I will just speed it up a bit. As you can see on Unity Asset Store, you can find a lot of different models, and that's pretty much it. Thank you for your attention.
Hi, my name is Ignacio, and today I'm going to present our project of the semester, which is the 3D model of the drivetrain system for a high energy efficiency vehicle. So this project is part of the of a competition organized by Shell. So my task in this project was to develop the 3D model of the drivetrain system of the car, which we can see here on the left side of the presentation, the rear part of the car, which has the wheel and all the drivetrain system, which is composed by several different parts. The most important one is the frame, which can be seen on the top corner at the right, which is composed of several aluminum frames and tubes. The main objective of this drivetrain was to achieve stiffness and lightweight, and also to be very easy to assemble and disassemble. The results that we achieved with this project was, from one part, we got all the calculations, the documentation for example, the efficiency of the motor and the efficiency of the drivetrain. And for the other part, we achieved all the engineering drawings and the manufacturing drawings for to manufacture all this drivetrain to give to the next group that will be working on this project this semester, for them to be able to build this and implement it into the current car. Thank you very much.
Can you hear me? Yeah. Okay, my name is José Eduardo, and together with my previous colleague Ignacio, we did this topic of the 3D model of the drivetrain system for a high energy efficiency vehicle. The introduction to this is that the aim of this project is to develop the drivetrain system for a vehicle that's going to compete in a tournament named EcoShell Marathon. This EcoShell Marathon, the goal is to build and design a car that can travel the longest distance possible, which means highest efficiency, with just 1 liter of gasoline. Here in the Hochschule Karlsruhe, there's a team that has been competing since 2011. And in 2018, they got their highest record, which is with 1 liter of gasoline, they travel 578 kilometers. Okay, one of the tasks I developed in this project is the tensioning mechanism for the drivetrain system. The tensioning the mechanism for the belt, it's important because you don't always want to have like a constant tension. You need to have like a variable tensionist mechanism. And the idea behind this is pretty simple. We have this L-shaped profile, which is attached to the small pulley. We call this circle right here, the small pulley. And it's pretty much attached to the frame, as you can see here. And this is the mechanism itself. It's pretty much a spring. And this guy little here that's called a turnbuckle. A turnbuckle pretty much lets you twist this small mechanism so you can verify the tension between these two pieces. Another one of my tasks here was the finite element analysis. So here we can quickly see how it's how the chassis reacts when the braking force is applied. Here's a little bit more information. The highest stress achieved was 70.74 megapascals. As we know, the plastic deformation of the steel starts at 210, so we still have a 2.77 safety factor, which concludes that it's gonna last and it's reliable. And that's pretty much it. Thank you.
Hallo. Es wird nicht größer, wie man das macht. Hm? Das da. Ah, hier, das. Okay. Welcome to my presentation about my bachelor thesis. I'm going to present about energy harvesting system for a wind speed sensor for the company VK Mobile Control. This is the sensor here, and the sensor is on top of a crane. And the problem about it is it's battery powered, and the people who work with the crane has to change the battery every 3 months. That's why they want a self-powering system. And my task was to do the first prototype of it. At first, I need to do the energy harvesting with 2 sources. One, the wind speed and the iteration. And to manage this, I have to build up a new electronic circuit, a management system. A part of my work was to simulate it. Here you can see on the left side the simulation of the solar cells and a part of the electronics. Then I had to design the PCB for it, and there was 2 different types of the circuits I designed there. So it was like an APAL board for the next people who work with it. And then I have to assemble the PCB. And on the downside, you see an SMD solar cell I choose for my project. Then the mechanical part was I need to construct an adaptive prototype for the wind speed sensor. And there you can see it on the left side, and on the downside you can see a test stand for the generator I used. And here's a picture from the test stand. And then at end of the presentation, you can see the result of the prototype. And the last part, and mostly the biggest part of my project, was the calculation how much energy I can harvest from wind speed and from the solar cells. For the wind speed, it was important to gather the information from the local wind data here in Karlsruhe, and the geometrical data of the wind speed sensor I had, and then calculate how much wind I can earn with it. And also for the solar cell, it was important to know the characteristic of the solar cell and the iteration data in Karlsruhe to calculate the potential energy I can win there. Yes, and this combined with the efficiency analysis of the electrical part, I could answer the question how much of the battery capacity the company could reduce with the system. And with the first prototype, and the picture you can see on the right side, you can reduce the battery by 50%. Yes, that was my, thank you for listening. That was my presentation. That's it. Okay. Arthur, can you hear us?
Can you please show your picture? I sent all the emails and the address for the link to 4 persons. 1 person is there, this is Arthur. But there is no picture from Arthur. he's here or no?
Ich habe nur die Präsentation vorbereitet. Ah, er sagt was.
No, he can present.
Er sagt was.
Man
hört ihn
hello Arthur, how are you? Hello Arthur, how are you? No. Nothing to hear, I will go back. Maybe there is
Can you hear me?
Yes.
Hello, can you hear me? Can you hear
Yes,
me?
we hear you.
Yes, we can hear you.
Okay.
Should we start your presentation?
Yes, you can start your presentation.
It is going with a lot of delay. The problem is going with a lot of delay. I'm saying something. Yeah, like I'm saying something and then I'm listening myself in echo like 2 minutes after, a minute after.
So I think Moment, wir haben jetzt 1.
Und das sind 4.
Ja, aber er muss die Präsentation.
Er braucht die Berechtigung.
Also zulassen und
Steuerung.
aufzeichnen. Normalerweise kann der hier, ich sehe seine Präsentation.
Ja, aber er muss hier die Seiten wechseln.
Aber er kann sie doch wechseln.
Er hatte die Berechtigung.
Can you please change your presentation, the sheet of your presentation? Arthur, can you present your presentation? Do you hear me? Arthur, do you hear me? Arthur, do you hear me? No. Mikrofon, Bildschirmaudio, das ist ja furchtbar. Warum? Da kommt doch hier. Das müsste hier reingehen. Ausgang integriert. Arthur, do you hear me now? Do you hear me now? No. Warum das Auto weiter Einstellungen? Ja gut, er ist im Chat, aber ich suche hier, damit wir den Ton hier drauf bekommen.
Okay.
Ja, bleiben wir ruhig mal hier. Da ist alles auf 1, da ist alles drauf. Aber jetzt muss er... Normally he has to hineinlassen. Okay, next one. Du hast jetzt das Bild vom Mac Pro, schaltest du auf 4, bitte. Okay, Arthur, Ja, na, er hört uns noch nicht. Er hört uns noch nicht. Jetzt ist auf 1, kommt nochmal als Blackmagic Design. Arthur, do you hear me? No. HDMI, Ausgang integriert, Blackmagic Design. Wir sind hier im Blackmagic Design. Eins, zwei, drei, das ist jetzt, hört man hier, wunderbar, das hört man. Und dann müsste es auch hier reingehen in den Kopfhörer und da. Warum ist das im Lautsprecher? Das im Lautsprecher, aber im Mikro müssen wir in Blackmagic drin sein. Moment. Das ist ganz komisch. Im Master haben wir jetzt hier was.
1, 2, 3, das ist jetzt hört man hier. Wunderbar, das hört man. Dann müsste es auch hier reingehen.
Guys, listen to something? To a presentation?
I don't know who's talking.
Me neither.
Ganz komisch. Master haben wir jetzt hier was. 1, 2, 3, das ist hört man hier. Wunderbar, das hört man.
Guys, listen to something? To a presentation?
I don't know who's talking.
Master haben wir jetzt hier was. 1, 2, 3, das ist hört man hier. Wunderbar, das hört man.
Guys, listen to something? To a presentation?
Im Moment gibt es noch Probleme. Ich weiß nicht, an was das liegt. Schlechte Netzwerkqualität. Der Anruf könnte betroffen sein. Blackmagic, das sind wir eigentlich drin. Ja, das ist alles in Ordnung.
Im Moment gibt es noch Probleme. Ich weiß nicht, was das ist.
Wir haben die zweite, da geht der Ton rein. Und da ist der ganze Ton drin, ja. Und das geht normalerweise hier. Und da ist Blackmagic drin. So, da ist die Blackmagic jetzt. OBS. So. Bitte? Ja, also er kann ja präsentieren. Also, aber das. So. keiner im Chat drin ist.
Die müssen es gesehen haben.
Arthur, wir haben das. Du hast jetzt was drauf? 1.
Ja, das ist die 1. Willst du 4?
Aber die 1 ich will 4 drauf haben. 4 drauf haben und Moment.
Hier den Ton ist aus, aber
Ja, ja.
Hat er selber gemacht.
merkst du, bei ihm den Ton ist aus, glaube ich. Und von der Frau auch.
Ja, natürlich, der Arthur soll jetzt präsentieren. Arthur, präsentier doch bitte. Arthur, bitte präsentieren.
Ich kann auch unten fragen, ob jemand von denen ihm schreiben soll.
Ja. Ja, kann man einfach nochmal machen. Can you please start the presentation? Ich weiß gar nicht, was das da vorne ist. Der musste seine Präsentation teilen. Lass das da drin dran.
4 oder 1?
Lass 4 alles dran. 4 ist die Präsentation. Aber ich sehe doch seine Folien, weil die eine Folie, die vorne ist jetzt, der Rechner, den können wir, der ist ja jetzt gar nicht mehr aktiv, sondern wir arbeiten ja nur noch über sein. Und er muss teilen. Ich mache jetzt gerade mal hier. Da machen wir das mal rein. Und er muss teilen. Bitte? Moment, ich bin gerade noch bei, es kann noch sein, dass da hier nochmal Sicherheitseinstellung jetzt da ist. Datenschutz. Ja, ich nehme an, dass hier in den Systemeinstellungen irgendwas gemacht worden ist, oder? Ja. Ja, er muss so normalerweise, also normalerweise kann er seine Sache starten. Ja. Vielleicht können wir ihm nochmal schreiben, dass er, hat er ein WhatsApp oder?
Ja, also
dann soll doch einfach nochmal ein WhatsApp.
Soll er ihm schreiben?
Ja, er hat meine Nummer.
Wenn hier die Tür offen ist, ist meistens einer.
Ja, hallo, hallo. Wir sind gerade in der Live-Übertragung, deswegen haben wir momentan.
Das war auch schon alles, was ich wollte.
Ja, ja, alles klar.
Ciao.
Danke, ciao. So, So, was ich nicht verstehe, ist hier, sind vielleicht nochmal Bildschirmeinstellungen oder Apps. Eins, zwei, drei. Geht es jetzt? 1, 2, 3. Kann man mich jetzt hören im Chat? Kann man mich jetzt hören? Arthur, kannst du mich jetzt hören? Wenn du dein Mikrofon einschaltest, geht's besser und dann sing ein Lied, ein spanisches. Du hörst mich nicht? Nein. Hörst du mich jetzt? Nein, auch noch nicht. Auch noch nicht hier. Eins, zwei, drei.
Arthur on the phone, he cannot hear us, he cannot change the slides.
Yes, but Inhalte freigeben. Now.
You can. Te lo paso.
Sound einschließen, Inhalte freigeben.
I can share my screen. I can change the slides.
You can change the slides? No. You can share your screen. Yes.
Yeah.
Share your screen.
I think it's already done. Could you confirm that you are seeing the slides?
Yes, we see the slides, and if I can make it a little bit. Yes, now ultra lytics.
I'm changing.
Yes.
Present and then
Yes, but
give the voice to
you have to switch on your microphone.
Yeah. Okay, so I'm starting to present now. Okay?
Yes, but switch on the microphone first.
Yeah. The thing is,
No, your microphone is shut down. Your microphone is shut down. No.
Okay.
Yeah.
So welcome everyone. My name is Arthur Abuda, and I'm a student of the EU4M Master. And today I am going to present you a work that I've done together with my colleague Omer Abdallah. It is about object detection in adverse weather for autonomous driving. So we're basically working on a paper format work in which we are as a dissection of another paper that is relevant and treats state-of-the-art technologies, and we started the work just to trying to kind of analyze it and analyze what technologies work best, but then it quickly developed into something else. And as you will see later on, not only from me but also from my colleague Omer, we implemented other features. We used other tools to kind of improve upon the base work. So we took a reference paper from Kumar and its colleagues, and they were using an algorithm called YOLO V8, which is quite popular in the field of computer vision, and they were trying to use it to detect all sorts of objects in traffic in autonomous driving conditions. So we basically took this paper, replicated the results, and then confirmed that what they got was actually possible to do, even with quite lower computational resources as we have. Yeah, so we did this, and we saw a lot of opportunity for applying new technologies. So, for example, we developed further the topic of transfer learning. We took a very rich data set, very rich in images data set from KIT in Karlsruhe. And then we train our model first on a data set from the paper and then on the data set from KIT. And we saw how this pre-training affected the later stages of the training. In order to do this, we had to develop a custom code, which is available on GitHub. And yeah, we basically developed this code, which kind of took the dataset from KIT and made it to be in the same format as the dataset, in the same format as YOLO V8 uses. In this way, we made the data processing and adaptation, and we saw some quite interesting results, confirming that actually transfer learning is successful and it has usability in real-world applications. This is the results section. It is all from my part, but now my colleague Omer is going to explain more to you about it. Thank you for listening.
Hello, everyone. I am Omer. And now I'm just going quickly to talk about the results that we obtained from our work, and also to show a demo of what we did, because it's quite boring just to show numbers and codes. So the main motive for our project is that usually in autonomous driving, it is not a problem to detect cars or motorcycle or anything else in the street during the normal condition. But when it's like raining or snowing in the adverse weather condition, it's not that easy. So we took that work, as my colleague explained. We replicated the work. We get similar results to theirs. And while we are doing our replication, because the field of AI, I would say, is developing really rapidly, a new algorithm came out in the way. It's called YOLO V9, which is like an upgrade, supposedly an upgrade from YOLO V8. So here you can see our results listed in this table. For the YOLO V8, we tried all the different model of YOLOs. They have like 3 or 4 models: nano, and medium, large, and X. And this just represent how the complex is the model, what's the number of parameters and everything. So we first run just the model and on the first YOLO V8, and then we did the transfer learning. And what is interesting about the transfer learning is that actually we are trying to see, okay, what if we train this in the adverse weather condition and then just run it in the normal weather condition? Will it improve or will it be the same result? And as you can see here, we had used YOLO V8 nano model in the 5th row, if you can see, with Kitty. First, we just used the baseline model, which is trained on Cuckoo, and trained it in Kitty, and we got a 0.95 MAB50. And then when we did the transfer learning, as we did it in the merge, and then in Kitty, we get a better results of 0.97 MAB50. I don't know if I'm allowed to share my screen. There is a small demo I want to show, it's just a matter of seconds. Yeah, can you see this screen? Okay, here is the main motive of our project. You can see it here running in very windy and I would say storm condition. And then you can see it is detecting cars and trucks even in this harsh condition. And this is actually the models that we trained. We just downloaded this video to replicate these conditions, and we run the model. And as you can see it, I can actually take it a little bit forward. Even in such conditions, it can detect the cars and the trucks nearby in the driving. So I would say the main contribution we've made is just we explored the fact that transfer learning is doable when you have such conditions. It helped in adverse and also normal conditions, and we've seen that with YOLO V9, although it's the newest model, but it didn't perform as expected. Maybe the model needs some kind of optimization or hyperparameters tuning, and this is, I would say, like an area for future improvement. And that concludes our project for this semester.
Okay. So is the next one? The next one, please. Bum, 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 bum. Was ich überhaupt nicht verstehe.
Before you had a call, I think it's supposed to.
Die hören uns jetzt gar nicht.
We just go one after the other one. You share the screen and present your slides.
Wir senden denen keine Bildschirme.
Well, I think we are next. If Luis, can you put it in the beginning? We can start. Well, we are going to talk about our work in 3D object detection 2 in autonomous driving, but we did it with another focus. Luis, please. This is the order. Next. Our objectives were adapt work that was already done in GitHub, do a comprehensive examination with Kitty and new scenes datasets, and do make a perform evaluation. There are a lot of functional modules inside the autonomous driving system, but we focus on sensing and perception. In the case of sensing, we focus on next list and perception. It's very important for safety and efficiency. You can see here in the both images, like before it was done manually, all the parameters were chosen manually, and now we are just important information in understanding spatial layouts. Voxel nets, we work with voxel nets. We exclusively operate 3D point works with voxels, like little boxes. The box predicts the features, and yeah, we are going to talk about CNNs and the design later. Please, this is not a presentation, but okay, keep going, please.
Here.
Yeah, CNNs are a class of deep neural networks widely used in, as we already talked about, it will predict the objects, like all the parameters by itself instead of manually doing it like before. They extract features and it will be done by filters. There are several parameters that we are not going to talk about. Sorry, Luis, this is not a presentation too, but don't worry, we'll keep going. There are several details. We are going to talk about. The first one you can see in the red box, 2 additional downsamplings. Then the detail 2, Luis. It's okay, don't worry about it, we'll do it with this. Keep going.
Just one moment.
Is the one? Hold on. But don't worry, it was almost done.
So I'm sorry because there is no camera.
Which one? Mine?
Yes.
You can see me?
No.
Well,
there is no Lucia.
The rest can see me because I can, but
no, I can see you neither.
What?
No.
Now we can see you.
Please, can you share the presentation, please?
Yeah, I'm sharing right now on your folder. Okay.
And it's
the one in the Annette link. Before I look at it, is it?
Yeah.
I start.
Or just be like in after the CNN. Yeah.
Okay.
Those are the architectural designs we took into account: the objective function, the optimization, regularization, normalization, width and depth for the CNN. Detail 1 of the bottlenecks will be 2 additional downsamplings. Detail 2 would be parse height compression. Detail 3 would be spatially voxel pruning, and the last one would be sparse max pooling.
Well, okay. Right now, we will talk about the implementation. For implementation, we used two different kinds of input data. First, we use the Kitty dataset, and simultaneously, we use also the NUC input dataset. I will talk about the the end-use scenes. So let's go one moment to it. Okay, well, here it is. Well, the end-use scenes input dataset consists on a set of scenes, and in total is like 1,000 images from a lot of points of urban areas, especially in Boston and a village in Great Britain. And as you can see here in this diagram, it consists of all kinds of sensors. It includes radar, LiDAR, camera, EMU sensor as well. And here, in this case, we will talk about also how we implemented and the results we got. Okay, here you can see the configuration it takes and all the size. As you can appreciate, its size is too big. And as we were implementing this algorithm in our computer, we didn't. Our computer wasn't so big enough in space able to compute this. So what we did is train and test like the mini version in order to get the result, if it was worth to continue with the project or not. So let's go on with the results. Well, as you can see here, the parameters, also the evaluation metrics, like how the precision, the average parameter. Here, the metrics obtained. What we did was, as our project was to recognize objects from all kinds of sensors of a car, we first tried to detect 10 classes of objects, and we got these results. Then, as they were a bit, let's say, not so good results, we tried to focus just on 3 classes of results, which were a pedestrian, a car, and also a bicycle. And here is the table of all the parameters and the average precisions obtained by both the 3 classes and the 10 classes. As you can see here, these were not evaluated in the 3 classes. And well, that's it for the end scenes. Let's go now with the kitty model.
Yeah, Luis, could you please take it to the kitty slide?
Yeah. I think it's this one, yeah.
Yes. So yes, as my previous colleague Luis said about the end scenes, this is the second data set that we worked upon, the kitty one. So this data set was collected by KIT, and it had several images with lighter point clouds, and our main objective was to adapt the voxel next model to the kitty data set. And in this case, we were successful to get some results for 3 classes. The 3 classes that we detected were for class, cars, pedestrians, and cyclists. So we can move on to the results directly.
Yeah.
I think it's next. The results table.
Oh, one moment.
Yes, the upper one.
Here, this one.
Yes.
Okay.
So yes, here are the results. The results are kept in the bottom of the table, which is the voxel next, and we have compared the results with other state-of-the-art models from 2018 to the recent ones. So where our model stands is in the between. It has an average performance for the detection classes. So now let's see some sample images and the predicted detections in the next slide. So here it is a simple image, and at the left side you can see the image of the dataset, and the middle one is the top view or the bird eye view of the detection, and the rightmost is the image or the predicted output from directly the LiDAR sensor. So from here, the green bounding boxes are of cars, the yellow are for cyclists, and the can colored ones are for pedestrians. So here are only for cars. So in the next sample images, maybe we can see some cyclists and pedestrians. Yes, here. So we can see in the rightmost one, we can see a pedestrian which has been correctly detected, and the cars at the respective locations. So yeah, next. So yeah, here we can see some cyclists also right in front of the image, and it has been correctly detected. So yeah, so this image was a bit occluded. That means the detection difficulty was high in this case. So we gradually increased the difficulty and checked the efficiency of the train model. Next. Yeah, this was the most difficult detection which we found, and the results were quite satisfactory here. Like as you can see, there were a lot of pedestrians, a crowd of pedestrians, and the model detected it quite well. Yeah, next. So the conclusions would be yes, to improve the Kitty model by training it more. And since the model has a very good result on tracking options, so yes, the future work would be to work on the tracking for both NSYNCs and Kitty datasets. That's it. Thank you.
Well, that's it for our part. So I think right now it's time for the next project.
I will take advantage on that. Mr. Walter, there is a problem with my group. Basically, Solon and Valerie won't be able to make it in time. They are one at work, another is in the train without almost any coverture at all. So today it's impossible for us to make the presentation. Would be possible, because I think the final presentation is next Monday at the same hour. And the hour is an issue for us because we are at work. So basically it could be possible for us to record the video making all the presentation, which is much more easy for us in terms of time, and send it to you.
No, it's a presentation, and you present your things at this time. And you study, and this is one very important thing, that everyone is here. You can do it by online, and you can take your phone, and everything is all right. So we do everything that you can do this presentation on time.
But if we are at work, what can we do? I cannot tell my boss I'm going to do a presentation.
Speak with your boss and say you have a presentation at 5 o'clock or 5:30, and then I think everyone could do this.
Okay. And if not?
If not, it's not possible. Say to your boss, and you have to finish, and I think that's very easy.
Yeah, I mean, it's easy to say, but probably if my boss say, hey, no, you have to do this, or Valerie's boss, or even Solon, because he is not able to get it in time.
So I'm sorry, I don't understand it, because did you study still, or what happened now?
I'm studying still, but
you are EU4M student.
Yeah.
So, and this is the most important thing. You get a master, and I can't understand what happened, because you study and you make a master, and this is your most important thing.
Okay, we will try, but I mean, I don't know what my boss or Valerie's boss will tell us, but we will try. I don't know. But if not, maybe we need I don't know, some kind of permission, because in the end, it's laboral job, laboral timetable. I mean, I'm working from 8 to almost 6 p.m. So if the presentation is at 5 p.m., I don't know if I can go outside my office and with the mobile make a presentation. I don't know. I will try, but
I'm not the right man. Ask Mr. Kipfmüller or ask Mike. What happened in such a case? I don't know.
Okay, but however, today is not possible because Valerie is still at work and Solon is in a train, so it's impossible for us to make the presentation.
We have 6:30.
Yep. And I'm at work. I mean, I can make the presentation by my own, but today it is supposed that is a trial, right? It is not the final presentation.
I can only say the presentation is at 5:30, and if you come, it's good. And other things, Mr. Kipfmüller has to decide, or Mike has to decide what happened. But this is no teamwork. I think if you make a study, everyone can make a presentation together. This is normal teamwork in a study.
Okay. But today is not possible for us unless I do the presentation all by my own, because they won't be able to connect on time.
Yes. So, but I think it's very important to make exercise and to because I think if there is a sheet and someone other has to control the sheet and someone other is speaking, so that this doesn't work. I'm a little bit astonished about the things which happened now. And I think all the people are here and they are in the classroom, and I will go inside because and I think everyone should make exercise and has to work, and if you can do it online, so you do it online, and please, yes. I think I'm a little bit how to say, I'm a little bit astonished.
Okay. So sorry about that, but
about your work and about your studies, this is not the manner I I normally see if you make a master. That's new kind of learning for me. Okay, so I think we will finish, and we have a lot of things seen, and I think everyone has to yes, has to do more practice, and you can do it between each another, and I will prepare here everything, so I hope it will work next week.
Okay, we'll try to connect everyone next week. Hope that it suits in timetable, but not easy for our side. But yeah, we will try our best.
All
Thank
right.
you.
Thank you.